Hello and welcome to another video of the marathon series. Today's topic is functions. This is relevant for AS students who are doing the AS maths this year. Let's start with the questions. Question number one says the function f is defined by f of x equals to ax plus b, where x is an element of the set of real numbers where a and b are constants. It is given that f of 2 equals to 1 and f of 5 equals to 7. So I think this is a simple question on just functions, and I can use x and y values. So when the x value is 2, the y value is 1. So I get one equation that goes to a plus b equals to 1, and I can make another equation that is 7 equals to 5a plus b, and I can solve these simultaneously. Of course, when this question is there on the exam, the examiner would expect you to solve simultaneously before coming up with an answer. um, so I subtract, these cancel out, and it gives me minus 3 equals to minus 6. A is therefore equals to 2, and b is therefore equals to 2a plus b equals to 1, b equals to minus 3. Then it says solve the equation f of x equals to 0. So I will have to construct f of x first. What is my f of x? F of x is basically 2x minus 3. F of x is therefore 2 f of x minus 3 is f of x. So I'm going to say 2x minus 3 minus 3 should equal 0. So that gives me 4x minus 6 minus 3 equals to 0. X equals to 9 over 4, which is 2.25. So a relatively simple question from the early past papers. So on to question 2. It says functions f and g are defined by this. Find the values of k for which the equation this has two equal roots. So this is a question on quadratics. When I say equal roots, b square minus 4ac should be equal to 0. So I am going to go with f of x equals to g of x. So when f of x equals to g of x, I have k minus x equals to 9 over x plus 2. Cross multiplying this gives me kx plus 2k minus x square minus 2x equals to 9. X square plus 2x minus kx plus 9 minus 2k. So I can then pull out a, b, and c. A is 1, b is 2 minus k, the coefficient of x, and c is 9 minus 2k. So b square minus 4ac should equal 0. It's a long question, it's a 6-mark question. So let's just take this to the next page. 2 minus k squared minus 4 times 1 times 9 minus 2k equals to 0. So I get 4 minus 4k plus k squared minus 36 plus 8k equals to 0. K squared plus 4k minus 32 equals to 0. I have two values for k, 8 and minus 8 and 4. I will use the quadratic formula. Let's not do it directly. Minus b plus minus b square minus 4ac. So I get k as minus 8 and k as 4. Then it says and solve this equation f of x in these cases. So I have to again go back and say that f of x equals to it was k minus x. So I'm going to say that the first value of k that I'm taking is minus 8. So it's minus 8 minus x, and g of x as usual is 9 over 2 9 over x plus 2. So what I can do is I can solve these again simultaneously. I would get the same result of solving simultaneously that I've gotten here. So what I can do is I can take this equation directly and say that once I'm going to take k as minus 8 and then k as 4, so it's going to give me the same solution as what solving these two simultaneously gave me. Okay, you can check if you want, but I'm pretty sure I'm going to get the same answer, minus 8. So x squared plus 10x plus 25. I solve for x and I can see that it should be minus 5. I again pick this equation up and this time I use the value k equals to 4. Yeah, x squared plus 2x minus 4x plus 9 minus 2 times 4. X squared minus 2x plus 1 equals to 0. X equals to 1. Okay, so I have two solutions, x equals to 5 minus 5 and x equals to 1. And solve the equation in these cases, and I think you just need to find the values of x, not the values of y. Let's just solve fg of x when k equals to 6. So now this time f of x is 6 minus x and g of x for part 2 is 9 over x plus 2 as before, and this is telling me fg of x equals to 5. So I will have to construct fg of x first, which is 6 minus gx. So 6 minus 9 over x plus 2, and they're asking me the question equals to 5. 6 minus 5 equals to 9 over x plus 2. So x plus 2 equals to 9, x equals to 7. And that is the solution to the second part. Then in part 3 it says express g inverse in terms of x. So I need to find g inverse. I'm going to make it simple. I'm going to say that y equals to 9 over x plus 2, and I can make a replacement and I get this. So g inverse of x is therefore 9 over x minus 2. That was a long question. Let's look at the next one. It says functions f and g are defined by 4x minus 2k. 4x is from the set of real numbers where k is a constant. G of x is this. Find the values of k for which the equation fg of x has two equal roots. So fg of x, 4 times g of x minus 2k, 4 times 9 over 2 minus x minus 2k is equals to x, and this equation has two equal roots, which means that b square minus 4ac is equals to 0. So 36 over 8 36 over 4 minus 2 minus x minus 2k equals to x. Now I could multiply this whichever way I wanted. I am choosing to do this and then cross multiplying. So 36 equals to x plus 2k 2 minus x. 36 equals to 2x minus x squared plus 4k minus 2kx. So bringing everything to one side, okay, pulling out ABC, A1, B 2k minus 2, C is 36 minus 4k. B squared minus 4ac should equal 0. So 4k squared minus 8k plus 4 minus 4 into 36 gives me 144 plus 16k. So 4k squared plus 8k minus 140. I'm putting this on a calculator. I hope I get the right answers. 5 and minus 7 are the values of k. Then it says determine the roots of the equation for the values of k found in part 1. So I'm going to again use the equation that I got from here and try to solve again. So my equation is x squared plus 2kx minus 2x plus 36 minus 4k. I'm now trying to find the values of x. So I'm going to use k5 first and see what do I get. X squared plus 10x minus 2x plus 36 minus 20. I've used k equals to 5, so x squared plus 8x plus 16. So x equals to minus 4. When I use k equals to minus 7, let's see what I get. X squared minus 14x minus 2x plus 36 minus 4 times minus 7. So I get x squared minus 16x plus 64, I think. Yeah, 64. So I get x equals to 8. Those are the correct answers, minus 4 and 8. Moving on to the next question quickly, it says find the set of values of x for which f of x is greater than 15. So I think this is a simple question on quadratic inequalities. So I'm going to solve after converting it into an equation. I am going to find the two values of x, then draw a small sketch, and then say that I want the values that are greater than 0. So this part and that part, and I'm going to say that x is less than minus 3 or x is greater than 5. Then let's look at part 2. Part 2 says find the range of f and state with a reason whether f has an inverse or not. So in order to find the range of a quadratic function, I must have its turning point. So my function is f of x equals to x squared minus 2x. In order to find its turning point, I can use the x coordinate of the turning point formula, which is, or I can use my calculator, minus b over 2a. So minus b over 2 times 1. So I get 1. When I calculate f of 1, I get 1 squared minus 2 times 1. So it's minus 1. So this graph is going all the way. It's not stopping anywhere. It's just there at 1 comma minus 1, which means that the axis should be somewhere around here. Okay, so I can say that the range of this graph, since it's not a restricted domain, the range of this graph is y is greater than or equal to minus 1. Why? Because the graph is extending all the way up from minus 1 and going up straight up. Then it says state with the reason whether f has an inverse. No, f does not have an inverse because it is not 1 to 1. 1 to 1. That is always the reason for having inverse or not having an inverse for that matter. Then it says show that the equation has no real solution. So I could show it in multiple ways. Let's first find out gf of x. Space is a constraint here. F of x is x squared minus 2x. And g of x is 2x plus 3. And I want to prove to you that gf of x equals to 0. So gf of x is 2 times f of x plus 3 um, equals to 0. So 2x square minus 4x plus 3 equals to 0. Now, in order to prove to you that it has no real roots, either I could calculate b square minus 4ac and show that it's less than 0, or I could go ahead and put in the quadratic formula only, and at the end say that I have non-real roots emerging from the quadratic formula. B square minus 4ac. 4 plus minus 16 minus 24. So you get 4 plus minus root of minus 8. You said these are complex, therefore no real roots. Okay, then it says sketch in a single diagram the graph shows gx and g inverse, making clear the relationship. So g is a straight line function. Okay, when I want to find out the inverse of a linear function, or sketch the linear function only, I just need to find out its intercepts, and I'm going to say that g of x equals to 2x plus 3. From the equation itself, I can see that the y-intercept is 0 comma 3. I can quickly calculate the x-intercept. I can say that 0 equals to 2x plus 3, and this gives me minus 3 over 2, which is the x-intercept. So I have minus 1.5 comma 0. So I'm going to make a small sketch. 1 2 3, 1 2 3, 1 2 3, and 1 2 3. So the original graph is at 0 3 0 0 3 and minus 1.5. The original graph looks something like this. That's g of x. Now for g inverse, what I'm simply going to do is reflect these points in the line y equals to x. So 0 comma 3 becomes 3 comma 0. So this comes up here, and this point gets reflected here. Minus 1.5, 0 comma minus 1.5, and the line looks something like this. I should actually get it to intersect, because that is what the inverse is about. That it does intersect at a certain point. And now, making clear the relationship, I know that the relationship is the line y equals to x, so it's a reflection in the line y equals to x. So I make a dotted line here and label it y equals to x. If you're not labeling it or not drawing the line, you will lose a mark unless you've stated it separately in a sentence. Okay, moving on to question number 5. It's a longer question. Let's look at that. It says the function f is determined by this for find the set of values of p for which the equation has no real roots. So I am going to go with no real roots. This says the function f is defined by f of x equals to 2x squared minus 6x plus 5. Find the set of values of p for which this has no real roots. So again, a question on quadratics. So part 1, 2x squared minus 6x plus 5 equals to p. 2x squared minus 6x plus 5 minus p equals to 0. So a is 2, b is minus 6, c is 5 minus p. No real roots, therefore b square minus 4ac is less than 0. So b square minus 4ac is less than 0. So 36 minus 40 plus 8p is less than 0. 8p is less than 4, and p is less than 4 over 8. Just p is less than half. Then it says the function g is defined by this for x is between 0 and 4. If I express g of x in the form this, where a, b, and c are constants. So part 2 is just about completing the square. So 2x squared minus 6x plus 5 is equals to ax plus b whole square plus c. So ax squared plus 2bx plus b squared plus c. So ax squared plus 2abx plus ab squared plus c. So comparing coefficients tells me that a is equals to 2 and that minus 6 is equals to 2ab. So 2 times b, b is minus 6 over 4, which is minus 3 over 2, and ab squared plus c is equals to 5. So 2 times minus 3 over 2 whole square plus c equals to 5. Half. Okay, c is half. So I've expressed it in the form 2x minus 3 over 2 whole square plus half. Then it says find the range of g. The only way that I can find the range is by a sketch. I know it starts from 0, it ends at 4, and there's a turning point in the middle, and the turning point is at, if I were to use this form, 3 over 2 comma half. So I'm going to use this form and then try to draw it by first calculating what f of 0 is. So given that I have the correct form, I can just go on and say 0 minus 3 over 2 whole square plus half, although the other line makes it easier. I am going to get 5 out of this. Then I'm going to calculate f of 4, and 4 minus 3 over 2 whole square plus half. You could use the original form of the equation as well, and that should give you the correct answer as well. So 4 minus gives me 13. So when I sketch this graph, it looks something like this. So 3 over 2 comma half, 5, 10, and 15. Okay, so graph looks something like this. At 0 it's at 5, and at 4 it is at 13. So the graph is going to look something like this. Okay, that is what I wanted to find the range. So the range is now y is greater than half, greater than or equals to half, and less than or equal to 13, because the endpoint is at 13. So that's the correct answer there. The next part says the function h is defined by this, where k is a constant, and I want, there's a domain, state the smallest value of k for which h has an inverse. I know that if I want this to have an inverse, and I know that my graph is supposed to stretch till 4, and I'm going to stop at a certain point, what I'm going to always stop at is the turning point. So I'm going to write that if what is the part that says part 4? So part 4, if h has an inverse, then it is cut at the turning point. And what is the starting value, the starting value for x then at the turning point. So then if I cut it from here, I can say that my graph will stretch from 3 over 2 to 4. Therefore k is 3 over 2. That's the lowest possible value that k could have. If k was lower than this, then the turning point would have been crossed and the graph would no longer be 1 to 1. Remember that inverse is only possible for functions that are 1 to 1. Moving on. Then there's for this value of k, find an expression for h inverse. I know that the inverse function for a quadratic can only be obtained from the completed square form. So I have x minus 3 over 2 whole square plus half. I'm going to write y plus half, y minus half, and then divide by 2 on both ends. There's a divide by 2, so this becomes y over 2 minus 1/4. Now I'm going to put a root sign and say that there are two possibilities with a plus and a minus, but since my graph is to the right of the turning point, I'm going to put a plus outside and say that this becomes y over 2 minus 1 over 4 equals to x minus 3 over 2. And the the squares cancel out, so 3 over 2 plus root of y over 2 minus 1 over 4 equals to x. So h inverse of x is 3 over 2 plus root of x over 2 minus 1 over 4. Yeah, they've taken an LCM inside. That's your poll. Let's look at the next question. It says, although I've worked on the graph, let's move this to the side a little so that you're not confused as to what's going on. Okay, this is the diagram, shows the graph of this where f of x equals to this for x is greater than or equals to 0. You should understand that this is a rational function. It's going to go to infinity at some point, so the asymptote is there. Find an expression in terms of x for f inverse of x and explain how your answer shows that f is a f bar of x is a decreasing function. Now this is differentiation, and I'm going to skip this part. I'm just going to come up with an expression for, oh okay, I don't have an expression for inverse, so I'm just going to leave that part out. It says this is a differentiation question. Let's look at the other parts of this. Find an expression in terms of x for f bar inverse of x and state the domain. So I'm going to say that y equals to 6 over 2x plus 3. Okay, so 2x plus 3 equals to 6 over y. 2x equals to 6 over y minus 3, and x is therefore 6 over 2x 2y minus 3 over 2. So this becomes 3 over y minus 3 over 2. So that's f inverse of x equals to 3 over y minus 3 over 2. Then it says, and find the domain of inverse. Now from our lecture, we know that the inverse of the domain of the inverse is equals to the range of the original function. Now I have the sketch in front of me. I should know where it starts from and where it's headed towards. I know that rational functions head to infinity, so there's no way that this would touch the x-axis. So I'm going to say that I know one of these boundaries, that y has to be greater than 0. It has to be less than something else, but it's never going to touch 0. Therefore the range should have one component as y is greater than 0. What is the other boundary? Let's plug in 0 in place of x and see what we get. We get 2. So it's less than or equals to 2 but greater than 0. If that is the range of the original function, then the domain of the inverse will also be the same. X is greater than 0 but less than or equals to 2. Then it says copy and the diagram on and your sketch, making clear the relationship between the graphs. To be honest, I will just make it on this only and tell you what to do. Okay, so I know that this graph is at 2. I know that the inverse function is also going to come up here at about 2. There is going to be a line y equals to x in the middle, passes through like that. Okay. Okay. For this to be reflected, understand that this side will now appear on this side. More like that. And this part will become this part. So I'm going to first join this part and say that that is the starting point of my inverse, and shape should look nearly the same as that one, and the graph is going to stretch like that. Okay, I think I've got it. Yeah, that should work. Although it should, they should, all three should pass through one common point. Yeah, my hands are a little shaky. I don't know why. Okay, that looks like a fine inverse function. I didn't sketch it again, although the question requires you to do it. So on the exam, whatever the question tells you to do. Then there's the function g is defined by a simple linear function for x is greater than or equals to 0. Solve the equation f g of x. So I'm going to solve equation number 4, f g of x. So 6 over g of x, 2g of x plus 3 equals to 2. So 6 over 2 into half x. Have I seen something wrong? Okay, so this is equals to 3 over 2, not just 2. It's giving me a weird answer. So that will become 12 equals to 3x plus 9, and 3 equals to 3x, x is therefore equals to 1. That solves the question. Oh, there was a long page after that. Okay. Question number 7. The function f is defined by this. Sketch in a single diagram the graphs of f and f inverse, making clear the relationship between the two graphs. Okay, question number 7 says the function f is defined by this. Sketch in a single diagram the graph of f and f inverse, making clear the relationship between the two graphs. So it's a similar question, and I honestly think it's actually the same sort of graph as well. Let's quickly draw it. Okay, so I have f of x equals to 3x minus 2. So the y-intercept is 0 comma minus 2. For the x-intercept I'm going to give y as 0 and then solve quickly. So 2 over 3 comma 0. So making a small sketch. So I have one of the points here, and the other point is somewhere here at 2 over 3. So this graph is going to look like that. That's the graph of f of x. If I were to reflect these points in the same line, I would get minus 2 and 0. So that would put me at here on this green dot, and okay, then if I want to make the relationship clear, I can just say that I am going to draw the line y equals to x in the middle. Remember that it always passes through this common point, and therefore that's the relationship between the two graphs. Then part 2 says express gf of x in terms of x, and hence show that the maximum value of gf of x is 9. So g of x is basically 6x minus x squared. part 2, and gf of x. So gf of x should be 6 times f of x. So 3x minus 2 minus 3x minus 2 whole square. I want to find the maximum value. I know that this is a quadratic function. What I can simply do is I can say that I will have to find the turning point of this graph. So I get 18x minus 12 minus 9x square minus 6 into 2 is 12x plus 4, and 18x minus 12 minus 9x square plus 12x minus 4. So minus 9x square plus 30x minus 16. I want to find the turning point. Again, I've written this before. The x coordinate of the turning point is basically minus b over 2a. So minus 30 over 2 times minus 9. 30 divided by 18 is 5 over 3. So I get 5 over 3 as the x coordinate. I can calculate gf of 5 over 3, and that should give me 9, which is what I wanted to prove, that this is the maximum value, the turning point in this case, equals to 9. Then part 3 says express 6x minus x squared in the form a minus x minus b whole square, where a and b are positive constants. So I'm going to again do the same, completing the square that I've done before. 6x minus x squared equals to a minus x minus b whole square. So a minus x square minus 2bx plus b square. So a minus x square plus 2bx minus b square. Comparing coefficients. So plus a minus b square. Okay, just rearranging them so that I'm not confused. Minus 1 should equal minus 1. 6 should equal 2b, and b should equal 3. And then there's a constant, so I'm going to say that a minus b square equals to 0. A minus 3 square equals to 0. A equals to 9. Okay, that is for part 3. Then it says express h inverse of x in terms of x. So I am going to start doing the inverse. I think this is part 3. So this is part 4 that I'm doing now. So I know that the inverse of a quadratic will always start with the completed square form, which I just calculated. I'm going to say that this becomes 9 minus x minus b whole square. X minus 3 whole square. Okay. Then y equals to 9 minus x minus 3 whole square. X minus 3 whole square equals to 9 minus y, and x minus 3, the root, um, and then I need to decide whether I want the positive side or the negative side. For that, what I'm going to simply say is I need to see the sketch of the curve. This is no other way of predicting that. This is a sad face curve, and if you notice, the domain of this function is x is greater than or equals to 3. And if you also notice, the turning point that I had from here was 3 comma 9. So I can imagine that the graph would look something like this, but the domain is sort of restricting the portion that is behind the turning points. It's only the portion after, and we've learned in the past that if you have the graph going towards the right, then you only take the positive side of the root. So I get h inverse of x equals to 3 plus root of 9 minus x. Moving on, this is question number 8. It says functions f and g are defined by this and that. Obtain expressions for x, f inverse and g inverse, stating the value of x for which g inverse x is not defined. So I think the first is simple. I think I find it very simple to do a linear inverse. We've learned that in O levels as well, and that comes in handy here as well. So g inverse, sorry, this is f inverse of x. For g inverse, I'm going to again do y equals to 8 over x minus 3. This time I'm going to shift 8 over y, x equals to 3 plus 8 over y. And G inverse gives me 3 plus 8 over x. Then it tells me that I need to state the value of x for which G inverse is not defined. You should know that functions become undefined when the denominator is 0. So when is the denominator 0? When x is 0. So I'm going to say that x is not equals to 0. I have to say that out explicitly because that's what the question is asking me. Stating the value, so I'm going to say that x equals to 0 is making G inverse undefined. Then it says I need to sketch the graphs. I think that is simple and that's repetitive as well. Let's quickly do that. I need to make the function f of x equals to 2x plus 5. So the y-intercept is 0 comma 5 and the x-intercept can be calculated. Okay, so minus 5 over 2 comma 0. Okay, so that's 5, 5, 5, and 5. Okay, so this first graph is passing through 0 comma 5 and minus. It's going like that. The other graph is going to pass with the reflection of this, so this point is going to get reflected here and this one will be here, so I'm going to get this line. Okay, and then the line y equals to x will pass through both of these. So that was f of x, that was f inverse of x. Then in the last part it says given that f of g of x equals to 5 minus kx has no solution, so b square minus 4ac should be less than 0. So I need fg of x now. Fg of x can be quickly calculated. This is fg of x and I need to make this equals to 5 minus kx. So 16 over x minus 3 plus 5 equals to 5 minus kx. I think that makes it simple. This 5 will cancel out with that because it's going to go to the other side and get subtracted, and 5 minus kx. So that gives me 16 equals to minus kx squared. So this is a question on quadratics. I'll bring everything to one side. I can choose any side I want, it doesn't matter. Okay, and then has no solution. Find the set of possible values of k. So I'm going to say that b square minus 4ac is less than 0, is k, b is minus 3k, and c is 16. So minus b square minus 4ac is less than 0. So 9k square minus 64k is less than 0. Convert it into an equation. Solve for the values of k. K is 0 and k is 64 over 9. Make a small sketch. 0, 64 over 9. This is the k axis. And I want the values that are less than 0. So I'm open for these values. So I'm going to say that k is between 0 and 64 over 9. If I am correct, yes. Now let's look at question number 9. It says a curve has equation this, find the values of x for which this is greater than 9. So 2x square minus 3x is greater than 9. So 2x square minus 3x minus 9. So this is again a quadratic inequality. I'm going to convert it into an equation and solve for the values of x first. I'm using a calculator now. I think I'm quite tired of solving the same type of questions with quadratics again and again. 3 and minus 3 over 2. So I'm going to make a sketch for that. minus 3 over 2 and 3. And I'm going to say that I want the values that are greater than 0, so I'm talking about this and that. So x is less than minus 3 over 2 and x is greater than 3. Then part 2 says express 2x squared minus 3x in the form a x plus b whole square plus c. So 2x squared minus 3x equals to a x squared plus 2bx plus b squared plus c. So I get ax squared plus 2abx plus ab squared plus c. Okay, comparing coefficients then. A is 2, I think that's simple, and 2ab is minus 3. So b is minus 3 over 4, and ab squared plus c should equal 0 because there's no constant on the other side. So c equals minus 9 over 8. So I get my expression 2x minus 3 over 4 whole square minus 9 over 8. I can, using this, and state the coordinates of the vertex. Vertex means turning point. I think that's simple. 3 over 4 comma minus 9 over 8. Then the last part of the question says the function f and g are defined by this. When the values of k for which gf of x equals to 0 has equal roots. So for equal roots, I'm going to say that gf of x equals to 3 times f of x plus k. So 3 times 2x squared minus 3x plus k equals to 0. 6x squared minus 9x plus k equals to 0. Has equal roots, so b squared minus 4ac equals to 0. (81) minus 24k. 81 over 24 equals to k. That should give you 27 over 8. Okay, moving on to the last question of this marathon. This says the function f is defined by this, where a and b are constants. In the case where a equals to 6 and b equals to minus 8, find the range of f. So I'm going to say that if I want to find the range of f, I will have to sketch this curve and tell you that this is a quadratic curve. In order to sketch this, I need the turning point. So I'm going to say that my x coordinate of the turning point is again minus b over 2a. So minus 3. And f of minus 3 should give me minus 3 squared plus 6 times minus 3 minus 8, and that gives me 9 minus 18 minus 8, and it gives me minus 17. So when I sketch this graph, it's going to look like that because it has no restrictions on the domain. It's going to be minus 3 comma minus 17. So can I say that the range of values possible are all values that are greater than or equals to minus 17 is my range. Then part 2 says, in the case where a equals to 5, so f of x equals to a square x square plus 5x plus b. The equation f of x equals to 0 has the roots of the equation are k and minus 2k, where k is a constant. Find the values of b and k. Okay, so what I remember from my understanding of quadratics is that if something is a root, I can replace it instead of x and try to solve then. So I'm going to replace this k square plus 5k plus b. That gives me one equation. I'm going to also replace 2k minus 2k whole square plus 5 times minus 2k plus b. Whatever is the root must balance the equation. So I have k square plus 5k plus b and 4k square minus 10k plus b equals to 0. I can make b the subject and say that this is 10k minus 4k square and replace it here. K square plus 5k plus 10k minus 4k squared equals to 0. So minus 3k squared plus 15k equals to 0. So this is a normal quadratic. I could put this on my calculator and get two values out of this, k equals to 0 and k equals to 5. That is what my calculator is telling me. So it says where k is a constant, and if I took 0, then this would also be 0 and that would also be 0. It wouldn't be two different roots then. So I'm just going to say k equals to 5, and the roots are then 5 and minus 10 if I want them. Show that if the equation f of x equals plus a equals to a has no real roots, then b square minus 4ac. Okay. 3 f of x plus a equals to a. Now how do I find f of x plus a? I'm going to say that in the expression x squared plus ax plus b, I'm going to replace x with x plus a. So I'm replacing in the equation f of x equals to x squared plus ax plus b. I'm replacing x with x plus a. So x plus a whole square plus a times x plus a plus b equals to a. X squared plus 2ax plus a squared plus ax plus a squared plus b equals to a. So I get x squared plus 3ax plus 3ax plus 2a squared plus b minus a equals to 0. Now this equation has to have no real roots, which means that the b square minus 4ac of this equation is going to be less than 0. Now what is my original a that I use in quadratics? So here a is 1, okay. B is basically 3a, and whatever is the constant is c. So it's a little confusing, but that's how it's supposed to work. So I'm going to say that b square minus 4ac is less than 0. So 9a square minus 8a square. I think I want this to remain as b minus a. So I'm just going to say minus 4 times b minus a. So that's a squared and 4 times b minus a. That proves my point. I don't need to solve this further. That's what the question is about. And this brings us to the end of the first marathon. I will be back with another marathon for functions. There are more questions that I would want to do. Please make sure to like, subscribe, and comment if you have questions. Thank you.